All right, so boys and girls, friends. Talk loud. Yeah. All right, here we go. This is a shorter unit. This will be a shorter unit this time, which is fine. And again, your tests are not graded yet. I should have them done today. We're going to go down to, I'll be at the lab for about 4 hours today, so that'll give me time because, yes, though I enjoy hanging out and working and showing kids human body parts, it's cadaver lab. So it's where it's
freak you out.
No, it doesn't.
Have you ever had like a limb fall off?
I had not a limb fall off because they're usually still attached, but yes, I have cut off limbs.
It's like my
The most fun is once you remove everything here in this region, you pop the femur out of the hip. Awesome. It goes.
Does it make a loud sound?
How is that awesome?
Just, and then you put it back in and go. That's what it sounds like. I'm telling you, it's gone. I love it. It's great stuff. All right, warm up. First problem is on your sheet. So this is something that we're working on. So the things we're going to do today is we're going to do notes. We'll be done with notes pretty quick. And then we are going to go down to Miss Lewis's room real quick, grab a Chromebook, and you're going to log on and do a pre-test pretty quickly, okay?
Does it go on great?
No, but by you doing all the pre-tests and the post-tests for me throughout the semester, I will eliminate your lowest quiz score. So it allows you to take a mulligan on and test your quiz score. Sound like a deal?
Deal.
Just in case you had like a bad day and you're like, oh, I didn't do well. Okay. All right, first problem. I have 4 terms. 7, I have 2/3 y, I have 1/6 y, and I have -5. Still with me? So we are going to eliminate the fractions. We're going to clear the fractions. And if you had said, hey, what's this clear the fraction thing? It's where we multiply all the terms by the number that both 3 and 6 have in common. In this case, it would be 6. So I'm going to multiply that by 6. 6 over 1, 6 over 1, and 6. So I get 42 plus 12 over 3, which is
36.
12 over 3. Yep. Divided. Y minus 30. We good so far? Add 30 to both sides. I guess you could have done that. And then, let's see, plus 4y equals y. So this is all prior knowledge. This is stuff we've been working on, but I just want to make sure you're going to see it over and over and over again for a reason. We know it's very important, so we're going to get that. Thanks. Wrong class.
Oh, it is?
Yeah, this is second period right
Oh, she gave me a third
now. It happens. What's my last step up here?
Divide 3y.
Yep, divide each side by -3. So my answer is going to be negative. So I get negative. 3 goes into 7 twice. 1 left over. 3 goes into 12. 4 times. So there's that answer. Problem number 2. What should I do first? Should I add 8 and 3 together? No, why not? That's out of order of operations, right? So what am I going to do with the 3 first?
Distribute.
Distribute the 3 here and here. So I have 6a minus 8 plus 12a minus 9 equals -17. We good so far?
Yeah.
All right. Combine those together. I get 18a minus 8 minus 9. Oh, I guess I could have combined that 9. I'm sorry. Combine those together. And I'm going to tell you, there's a couple of you that had a big problem when this type of scenario took place. I had a lot of people tell me that there's no solution to this problem. Is that right or wrong?
Wrong,
Why?
because you could go even further, x equals 0.
Yeah, absolutely. So you're going to do this, divide each side. If I have 0 on top, my answer is 0. So the solution to this problem is x equals 0. It's not no solution. Is that okay so far? May I move to the next page? So that's kind of like prior knowledge we've done before. So now we're going to do solving linear inequalities, so graphing inequalities. So you have less than, so the less than sign points this way, and greater than points that way. Okay? So sometimes we'll say the alligator will eat the larger. So, but I don't know, that's all the cutesy I want to do. All right, so inequalities. You have less than, greater than. Less than and equal to, greater than and equal to. Sound okay so far? Pretty simple. All right, so graph the following inequalities. We're going to use an open dot or a closed dot. There's two different things, and I'm going to show you when. So if I were to graph this, I'm going to draw myself a line. I have 0 here, I have 4 here. I want x is greater than 4. So I want values that are bigger than 4. So that's like 5 and 6 and 7 and 8. So things to the right of it. But I'm not going to include 4, so I'm going to make it an open dot and shade this way. Okay?
Is that this here? Like, is that the...
We're starting it, yeah. We're going to build into it some more. Okay? So the reason it's an open dot is because there's not an equal sign associated. This one has an equal sign, so this one will have a closed dot. Open dot, closed dot. Even though it's going a different way, that's not what makes it open or closed. It's because you have the equal sign there. So the second problem, I want values that are less than -2. So if I get 0, -2, and it's important that you put 2 numbers at least, showing that you understand where numbers fall. But because there's an equal there, it's going to be a solid dot. Okay? Do I want values that are bigger than -2 or smaller than -2? Bigger. That says x is less than or equal to -2. So or equal to is because it's a solid dot. Values that are smaller. So what's a value smaller than -2? -3, and -4, and -5, and -6. Correct? So that means I want these values. Yeah.
So every time if it has an equal to, you shade
Solid.
the-
Solid. If it doesn't have the equal, open dot.
Okay.
All right, next one we have y is less than 0. So I'll have 0. Maybe I'll just put 1 so I understand that 1 is over there. Is it a solid dot or a closed dot?
Close.
Closed. And I want values that are smaller than 0. I go to the left, so -1, 2. So, solid dot or open dot? Why is it open dot and not solid? This had an equal, so it's solid. This didn't have an equal, so it's open. This doesn't have an equal, so it's
Open.
open. Okay? Z is greater than or equal to -10. So -10 stays down here. You know, get 0 over here. Does that be all right? Does it look like I'm going -9, -8, -7, -6? I don't have to mark it. Am I an open dot or a closed dot? Closed. Why is that?
Because it's equal.
There's an equal sign associated with it. Awesome. So I'm going to do a closed dot right here. Okay? I want values that are larger. I want values that are greater than -10. So greater than -10 would be like -9 and -8, -7, 6, 5, 4, 3, 2, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So do I shade to the right or to the left? All right. All right. How we feel? Yeah.
So if it's, let's just say if it's is greater than -10. So you would
It would be an open dot at the -10. Shade the same way. Cool. I think there's one more problem. Come on down. Two more. Oh, okay. Oh, shoot. Now we have -2 is less than x, which is less than 4. -2 is less than x, so x is some value that's got to be bigger than it, and less than 4. So what I'm going to do, I have -2 here, maybe 0 here, I have 4 here. Okay? Does everyone feel comfortable how I drew my number line? Okay? Do we have both open dots, both closed dots, or one of each? Both open. Why is that? Yeah, we don't have an equal. There's not an equal part. Okay, so we don't have this little line down underneath them. So both of these are going to be open dot. Now let's figure out where in the heck we need a shade. So those are my 2 points that I'm talking about. So -2 is less than x. So let's think about that. -2 is less than x. So if -2 is less than x, that means -2 is a smaller amount. So I'm going to the right. Good, right? So I'm coming this way. So that's the first part, and I'm just going to leave it there for a sec. And then x is less than 4, so x happens to be a smaller value than 4. So I'm going to shade in between my 2. Is that okay? Feel okay about those? Extend the page a little bit. All right, this one, 0 is less than or equal to y. So y happens to be, 0 is smaller than that. And then y happens to be smaller than 10. So talk to me. Draw my number line. What 2 numbers am I going to put in my number line right now? 0 and 10. Everyone feel comfortable with that? Yes, you can go 1, 2, 3, 4, 5, 6, 7, 8, 9, put in there. But I think you've got a pretty good understanding if you have that. Okay, are the points going to be solid, dotted, or open or closed, or one of each? One of each. Which one's going to be the solid dot? 0. Because of what reason? The equal sign. That little equal sign means that. The 10 is going to be open or closed? Open. Does everyone feel good about that? Is there anything about that you're like, whoa, time out. Where did this 10 come from? Okay, so now I want values that are going to be, my 0 is smaller than my y value, and y happens to be smaller than 10. So where am I going to shade on this page? What do you think? In between, outside, inside, upside down, don't shade.
Y is bigger.
So 0 is less than y. So 0 happens to be small. So this is like the endpoint. So I want values over here. And y is less than 10. So less than 10 is here. 0 is less than y. So that has to be over here. So I'm going to shade in between the 2.
Is there a, because the way I learned it like last year, is the greater than equal sign, wherever it's pointing to, you could draw that arrow. But for these, would it be the exact opposite because you have 2 of them?
So these are called a compound inequality. You're correct in what you're saying, as long as the variable came first. So if I cover that up, that's how you'd say it.
That's okay.
So, but then this kind of goofs up because it's now flip-flopped. The variable isn't first, right?
Yeah.
Yeah.
So what if the variable's on the left?
Oh, we'll get there. We're not there yet, but that's a great question. We're going to get there. Okay? Can I move forward? Please? Perfect. Oh, hey, skip one. All right. So now, we're going to use something called interval notation. Interval notation. Interval notation, you're going to use parentheses for an open dot, square brackets for a solid dot. Okay? So you're going to use parentheses when you have this and this. You're going to use square brackets when you have this and this, or that. Okay? That's the only difference so far. So I'm not using a number line. X is greater than 4. So what are numbers bigger than 4?
8.
5, 6, 8, 2,000, right? So I want to start at 4, and is it going to be a parenthesis or is it going to be a square bracket? Parenthesis. Okay, so that just tells me, hey, I'm starting here at 4. I'm going to go for numbers bigger than 4, so 5 and 6 and 7 and 8 and 9, and all the decimals and fractions that are bigger than that too, all the way up to infinity. Can we ever count to infinity?
No.
So infinity will always have a rounded bracket. It'll never be a square bracket. So this tells us that this is called interval notation. It's a way to represent where we're talking about on a number line. So we are starting at 4, not including it. So it would be an open dot if we graphed it. And then we're going to go to the right. Yes? Nope, 0 is not infinity. 0 is 0.
So wait,
Because this number line, this is what this number line is doing. 0 here, open dot going this way. So I'm shading forever that way. So that as I go this way, further and further and further, I get to infinity. So the last slide was, hey, we were graphing these. So this is going to infinity. This is going to a negative infinity. This is going to negative infinity. That's going to infinity. The ones down here were bound, right? So we'll get to that. Yeah.
So like if it was going to the left, it would be an infinity common form.
Yes. Good. That's exactly right. Now I want values that are less than -2. So values that are less than -2 are like -3, -4, -5, -6, -7, -8, all the way to negative.
hello.
Howdy. All the way to negative what? Cool. Thank you. Where do I get to in the negative direction? How far can I go in the negative direction? To infinity. Okay? So I want values to be coming from negative infinity, getting all the way up to -2. Am I going to include -2? Yes or no? Yes. So it's an equal sign underneath. So is it round or square? Okay, square bracket means you have the equal sign there. Rounded bracket means you don't. Okay? Infinity will always be rounded because you can't get there. I want values less than 0. Values less than 0 are all my negative numbers going all the way to what? I'm going to negative infinity. Where am I ending it? Where am I getting up to? 0. Am I including 0? It's one of your answers. 0 included, yes or no? 0 included?
No.
Why not?
It's not a equal to.
There's not an equal, so it's not included, so it's a rounded bracket. That's all it is. So this is just a way, it's called interval notation. You are to work through it. Okay? I want values that are greater than and equal to -10. Greater than and equal to -10. So what's bigger than -10? -9, -8, -7, -6, -5, -4, 10, 20, 30, 40, 50, 100, 200 million. So where am I going to? I want values that are bigger than -10. So is negative infinity a larger number than -10 or a smaller number? The further you go to the left, the smaller a number gets on a number line. Negative infinity is extremely small. It's negative. Positive infinity is extremely big. So I want values that are bigger than -10, also equaling it. So we're starting at -10. Square bracket at -10. Where am I going to? And the infinity will always, always, always be a rounded bracket because I can never get there. Why is it a square bracket?
Because it has an equal.
Has an equal. Okay. Problem number 5. Problem number 5. What do you think? We have starting points and endpoints, right? Starting points and endpoints. Okay? So, where am I starting? It's up there. Say it. -2. Where's it going to? Why did I use parentheses and not a square bracket on both?
Because there's
No equal sign. Okay? So this is the starting point, the ending point. We're talking about everything in between those. Okay, so interval notation, a little different way of looking at it. Okay, yeah.
So if there's an X in between, you don't use it at all. You just do negative.
You're just talking, so X represents
Oh.
-1, 0, 1, 2, 3. Okay? Alright, number 6. Do I have a square bracket on one of them and rounded on the other? Are they both square? They're both rounded. One is square. So I'm starting at 0 and I'm going to what? 10, rounded bracket. Done. Just start and end point. That's all it is. Start and end point. Okay. We have number lines, so we want to write the inequality. So x is greater than, less than, greater than or equal to, less than or equal to, -2. Am I going to the right of -2? So I want bigger values, yes? Does it have an equal sign underneath it? Why not? It's open. Next problem, where am I going? To the right. Where am I starting? Am I equal? Is there an equal sign also? Why is that?
Because it's shaded.
Shaded. Okay, x is greater than or equal to -4. Then we have to go back and do an interval on these two. Do I want values bigger than 0 or less than 0? Less? Is there an equal sign? No, it's an open dot. All right, so now let's do interval notation. Where did I start on this first one? At -2. Is it a rounded bracket or a square bracket?
Rounded.
Rounded because it's not equal to. And where is this line going to?
Infinity.
Infinity. Is infinity square or rounded?
Rounded.
Okay. Next problem. Do I have a square or round bracket up for my start?
Square.
Square. Where did I start from?
-4.
Where am I going to?
Infinity.
Okay. So this one, where am I really starting from?
0.
No. Where am I starting from? Almost. Where am I starting from? Negative infinity. And that's rounded. Where am I ending? At 0. Round or square? There you go. So this is the inequality here. This is the interval notation. This is the inequality, interval notation. Okay? All right. Define a variable and write an inequality in interval notation to model each of the following situations. Also decide if the data are discrete or continuous. Discrete means it starts and stops. Continuous means it starts and never ends. So starts and never ends means it goes to infinity or negative infinity. Make sense? The temperature of cooked chicken needs to be above 165 degrees. So where should we start? So it needs to be above it. So am I including it? Am I including it? It needs to be above it. Am I including it? No. Okay? Do we really think we'd get to an infinite temperature? No. I think the hottest you would get if you were in your oven would be whatever the top oven temperature would be.
500.
Yeah. So I'm just going to write this. Top oven / grill. Is that okay? I know that seems like a dorky thing to say, but we can't say that we can get the chicken to an infinite temperature. It'd never happen. There's going to be a certain point that. Yeah, I'd say that. Heck yeah, I would. Heck yeah. Your bank account cannot go below a $50 balance. So it can't go below it. So you can have a $50 balance, and then it can go up to the total amount of money in the world. Okay? Why is it a rounded bracket? Technically, it's infinity. I mean, it's not infinity, but they could keep printing more money, even though you don't have the gold standard any longer, which I was mistaken. But that's a whole different issue. To make the varsity team, you have to run the 100-meter dash in under 11 seconds. So so you need to run the 100-meter dash from 0 seconds up to 11 seconds. It has to be under 11 seconds. Obviously, it's going to be above 0 seconds. So that would be discrete. It's not continuous. These are all kind of discrete because you have the top grill temperatures, number one in the world, just because of the circumstance they're saying. The number of people on an elevator cannot exceed 12. So you could have 0 people on an elevator, right? You're at the top floor, you hit the button for the elevator to come up to you, the elevator might be empty, yes?
Yes. So
the elevator doesn't need somebody in it. It cannot exceed 12. So you could have 0, and you could have up to 12, and then you could have anything in between. Is that discrete or continuous? Discrete. Okay? So, little different. So this is a different type of thought process. Are you going to do real perfect on the very first assignment? No, I'd say try it. Try it, try it, try it. So your assignment is going to be page 31 and 32. Try it. See if you can figure it out. Now, while you're writing that down, I am going to go get us the Chrome card. We have just enough time to do it, okay?